Hi everybody. We're going to be talking a little bit about quadratic modeling and how we use quadratic functions in real life. Couple important things that we need to consider when we're using quadratic functions to model situations in real life. Number one, either A, you have to define what your variables are going to stand for, or B, you have to read carefully in the problem what the variables stand for. Most of the questions that you're going to be asked about these situations depend on your knowledge of what the variables actually stand for, and therefore what the question's asking you to find. For this example, we're going to be looking at a town that's planning a playground and that wants to fence in the rectangular space using an existing wall and 100 feet of donated fencing. The function f of x equals 100x minus 2x squared represents the playground, whereas x represents the length in feet and y represents the area of the playground in square feet. So you'll notice that we have a graph drawn of the function as well as the equation. And so the first question says, what is the maximum area of the playground? The second question goes along with this, and it asks what length of fence should be used to maximize the area of the playground. As you'll remember from when we were talking about the graphs, the point on a quadratic function that gives the maximum or minimum value is the vertex. Therefore, in order to answer any questions about maximums, minimums, highest or lowest values, most or least, any kind of thing that would indicate that you're looking for a maximum or minimum value, we're going to have to find the vertex in order to answer that question. So we can make that note for ourselves about the vertex. It'll help us answer questions 1 and 2. And we use the vertex for anything we want to maximize or minimize. And the really important thing about these questions is we need to pay close attention to x and y values. We want to make sure that we don't answer the wrong question correctly. Because even if you do it correctly, if you answer the wrong question, it doesn't do you any good in finding what you want to find. So taking a look at the graph, we'll notice that for 1, it's asking for the maximum area, which tells us we want the vertex. And since it's area, we want the y value. So when I look at the graph and I look at where the vertex is, I see that the vertex is at 25, 1,250. Since I want the y value for the area, we'll answer the question that it's 1,250 square feet. I swear I passed place value in 3rd grade, trust me. And then the second question, it's asking what length of fence should be used. So, and again, because of the word maximize and because of what the variable is defined as, this one we're being asked for the x value of the vertex. So I'm going to use 25 feet. We'll take a look at questions 3 and 4 later on when we learn some of the other material that we're going to on quadratic functions. But I want to look at question 5. It says estimate what area will be if you use a length of 20 feet. And again, going back to our variable definition, we know that x represents the length in feet. So since we're given 20 feet, that tells me that x equals 20. Therefore, 20 is my input value, and I'm going to put it into the function. So a problem where we're given the input and we have defined the output, that's like problem number 5. And you'll notice I can either look at the graph and see that when x equals 20, my y value is say about 1,200 square feet. So we'll answer the question like so. Now again, these are talking about what you find. You can also use the graphing calculator methods to find these values, as I've demonstrated in one of the other videos. You can also use any of your algebraic formulas for the vertex, or just simply inputting the x value to find the y value. Any of those methods will also work for answering this question. So basically, in summary, first you have to figure out what point the question's asking you to find on the graph. And then you have to pay attention to, based on the definitions of what x and what y represent, how are you going to use that information to answer the question that you're being asked.